Advanced Physics. How does energy produce work? Quarter 2, Week 4. Group 4 members: Daphnie Davad, Brylle Jumawan, Rhea Geolin, Farrah Elman, Rhisly Adalim, and Rylle Ramirez. Are you ready? Let's get started.
I will be the one who will discuss Lesson 1, Energy, the capacity to do work. So what is work? Work done on an object by an applied force is defined as the product of the magnitude of the displacement multiplied by the component of the force parallel to the displacement. For work to be done, 3 conditions must be met. Number 1, there must be a force acting on an object. Number 2, the object has to move a certain distance called displacement. Number 3, there must be a component in the direction of the motion. So for calculating the amount of work, here is the formula, where W is equal to work, F is equal to force parallel to the displacement, D is equal to displacement, and theta is equal to angle between the force and the displacement. So for the units of work, the SI unit of work is the Newton meters called joule. 1 Newton meter is equal to 1 joule. Other units used to express work are dyne centimeter or erg. 1 dyne centimeter is equal to 1 erg. In the CGS system, 1 joule is equal to 1.0 times 10 raised to the power of 7 ergs, and foot-pounds in the English system. For electrical applications, the unit of work is kilowatt-hour.
Hello everyone, this is Rhea Geolin and I am here to teach you how to solve the word problems. Now I will show you how to calculate the amount of work. The problem is you're supposed to pull your luggage with a force of 60 and parallel to the ground to your classroom, which is 50 meters away. What is the work done of your luggage? First thing first, we need to identify what is asked, the given, and the formula to use, and after that we need to solve the problem so that we can get the answer. So what is asked? The work done on your luggage, and the given are 60 and the force, 50 meters the distance, and we need to find the work. And after that, we can identify what formula that we will use. So the formula that we will use is work equals force times distance. Now we can start our solution. We just need to copy our formula, which is work equals force times distance. And after that, we will substitute. So it will become work equals 60 and times 50 meters. So the answer is work equals 3,000 joules. So 3,000 joules is the work done of your luggage.
Energy and its forms. This discussion explores the diverse forms of energy and their origins, all ultimately linked to solar steps. Mechanical energy is harnessed from heat and falling water, while chemical reactions like burning and digestion release chemical energy. The kinetic movement of steam molecules signifies thermal energy. Nuclear processes of fission and fusion transform water in nuclear energy. Radiant energy emanates from torchlight, and sound energy is generated by air compressions in a loudspeaker. Additionally, electrical energy is manifested through the movement of electrical charge in cables. And now, let's move on to kinetic energy. As we all know, kinetic energy is the energy possessed by bodies in motion. In finding kinetic energy, we only have one formula to use. KE equals 1/2 mv squared, where KE is the kinetic energy, m is the mass in kilograms, and v is the speed in meters per second. And now, Rhea will show you one sample problem in finding kinetic energy.
Calculate the kinetic energy of a 3,000 kilograms car traveling at 80 kilometers per hour. So the given of this problem is 3,000 kilograms, the mass of the car, and 80 kilometers per hour is the velocity. Since the unit of velocity of the formula is meter per second, we need to convert the given into meter per second. So 80 kilometers per hour changed to 22.22 meters per second. Now we can start our solution. KE is equal to 1/2 times 3,000 kilograms times 22.22 meter per second. And after that, it will be KE is equal to 1/2 times 66,660 kilograms meter squared per second squared. So the answer is KE is equal to 33,330 kilograms meter squared per second squared, or 33,330 joules. So the kinetic energy of the car is 33,330 joules. So that's how we solve the kinetic energy.
Potential energy is associated with forces that depend on the position and configuration of a body in its surroundings. First, gravitational potential energy, or the GPE, is the energy possessed by an object due to its position. It is determined by the height of the object above the Earth's center of gravity. GPE equals mgh. GPE stands for gravitational potential energy. M stands for mass. G stands for acceleration due to gravity. And H stands for height. Second, chemical energy. Chemical energy is the energy possessed by the atoms or molecules of a substance and is released or changed into other forms when the substance is involved in chemical reaction. And third, elastic potential energy. Elastic potential energy is an energy possessed by an object like a spring or any other elastic material due to its condition. Law of conservation of energy. Mechanical energy is the sum of the kinetic and potential energy of a system. In a conservative system, the total mechanical energy is constant. Law of mechanical energy. The sum of the kinetic energy and potential energy in a conservative system is constant and equal to the total mechanical energy of the system. TE equals PE plus KE. In an isolated system where there are no mechanical energy losses due to friction, delta KE is equal to negative delta PE. This means that all the kinetic energy and potential energy before an interaction equal all the kinetic and potential energy after the interaction. Initial kinetic energy plus initial potential energy equals final kinetic energy plus final potential energy.
Now I will show you how to solve the law of conservation of mechanical energy. So I have one problem. A 75 kilograms box falls from a bridge and lands in water 40 meters below. So we need to find its initial PE and the maximum KE, and lastly the KE and PE 25 meters above the water. So the given of this problem are 75 kilograms, the mass, 40 meters, the height, and lastly, the 9.8 meter per second squared, the gravity. So the formula that we will use is PE is equal to mgh.
So here is the solution. So for letter A, initial potential energy, and for letter B, maximum kinetic energy. So PE equals mgh. PE equals 75 kilograms times 9.8 meters per second squared times 40 meters. So PE is 29,400 joules. Now, let's find the KE and PE 25 meters above the water. PE equals mgh. PE equals 75 kilograms times 9.8 meters per second squared times 25 meters. PE equals 18,375 joules. Lesson 2. Power, the rate of doing work.
Hi everyone, I am Rylle Ramirez and I will be the one who will discuss lesson 2, work and power. So first, what is power? Power is the rate of doing work. It is measured in joules per second or watts. In getting the power, we have this formula. Power equals work done over the time. 1 joule per second is equal to 1 watt. 1000 watts is equal to 1 kilowatt. And 1 horsepower is equal to 746 watt.
Now we will learn how to solve for the power. And I've got one problem. So Brylle climbs a flight of stairs in 4.7 minutes. If he weighs 570 and the stairs is 40 meters from the ground, how much power will he develop? The given of this problem are 4.7 minutes, but we need to convert this into seconds, and it will become 282 seconds, and that is the time. The 570 and the weight or the force, and lastly, the distance, which is 40 meters. And the formula to use is P is equal to force times distance divided by the time. So the solution is P is equal to 570 n times 40 meters divided by 282 seconds. So the answer is P is equal to 80.85 watts.
Power and velocity. When a constant force performs work on an object and moves it at a constant rate, the power developed is equal to the product of the force and velocity. Calculus terms, power is the derivative of work with respect to time. If work is done faster, power is higher. If work is done slower, power is smaller. So for calculating the power and velocity, this is the formula. Power equals force times displacement over time and velocity times displacement over time. Therefore, power equals force times velocity.
Now, I'm going to teach you how to solve for the power and velocity. So how much power is developed by a jumbo jet that cruises at 380 meters per second when the thrust of its engine is 4,500,000 n? The given of this problem are 380 meters per second velocity and 4,500,000 n is the force. And we need to find the power. And the formula that we will use is power is equal to force times velocity. So the solution for this problem is P is equal to 4,500,000 n times 380 meters per second. So the answer is P is equal to 1,171,000,000 watts. So that's how to solve for the power.
Thank you for watching.